Across the dusty expanses north of Kasserine Pass in Tunisia on February 20, 1943, German tank commanders were witnessing something that defied every principle of warfare they had been taught. American Sherman tanks, 5 of them, were moving across broken ground with no direct line of sight between vehicles, no way to see each other through the choking dust and smoke. Yet they converged on German positions with a coordination that seemed almost impossible. There were no signal flags fluttering between vehicles, no flares lighting up the sky, no riders on motorcycles racing from tank to tank with urgent messages. Still, these American crews moved as one unified force, each machine covering the blind spots its neighbors couldn't reach, each group of soldiers knowing with absolute certainty exactly where their fellow tankers were positioned. Meanwhile, the German Panzer-IVs were equipped with radios they called the FUG-5, but those communication systems were struggling. Tank commanders hunched over their equipment, desperately trying to hear their own company leaders through waves of static that crashed through their amplitude modulation systems like interference from a powerful storm. Those German transmitters, considered state-of-the-art back in the 1930s, simply couldn't punch through the electromagnetic chaos when the tanks were rolling forward across rough terrain. The transmitters could only reach a few hundred meters in the best circumstances. To make matters worse, most German tanks carried only receivers. They could listen to orders coming down from above, but they couldn't transmit back what they saw or call for help when they needed it. What the Germans didn't realize was that the Americans possessed technology that hadn't existed just months before. The Sherman tanks were equipped with frequency modulation radios, FM systems that operated with crystal-controlled precision and pumped out 25 watts of transmission power. This clarity cut through engine noise and the deafening chaos of the battlefield with remarkable precision. 8,000 miles away, back in Detroit's factories, American assembly lines had created what would become one of the most decisive technological advantages of the entire war. It wasn't about armor thickness or the size of tank guns. The real advantage existed in invisible electromagnetic waves that connected every single American tank crew into what amounted to a unified network, something the Germans had never imagined was possible. This transformation had actually begun years earlier, on July 22, 1941, when the United States Army made an official decision to standardize radio equipment across all of their medium tanks. The military designated 3 radio sets for this purpose: the SCR-508, the SCR-528, and the SCR-538. Meanwhile, German forces were sweeping through the Soviet Union using battle tactics that absolutely depended on radio communication between their command vehicles. But American engineers working at the Galvin Manufacturing Company, a firm that would later become famous as Motorola, were quietly perfecting frequency modulation technology that would eventually make every German system obsolete. The engineering team behind this breakthrough included Daniel E. Noble, whose brilliant insight was recognizing how FM technology could be applied to military vehicles, and Henrik Magnuski, the principal RF engineer who tackled the fiendishly difficult problem of cramming sophisticated electronics into the harsh, vibration-filled environment of an armored tank. Their creation weighed 181 pounds and would transform every Sherman tank into a single node within what became the world's first genuine battlefield communication network. The BC-604 transmitter that they designed generated 25 watts of power, 2.5 times more powerful than the German FUG-5's maximum output. It operated across the 20.0 to 27.9 MHz frequency range and provided 10 different preset channels that maintained crystal-controlled stability. The SCR-508 included a dual receiver configuration that allowed tank commanders to listen to 2 different frequencies at the same time, a capability that proved absolutely crucial in actual combat situations. The genuine revolution, however, lay in the frequency modulation technology itself. Edwin Armstrong's FM innovation, which the military licensed for their own use, eliminated the constant static and interference that plagued the older amplitude modulation systems. While German tank radios picked up every electrical spark as nothing but noise and distortion, American FM radios delivered clear, crisp voice communication even when artillery rounds were exploding all around them. In November 1942, Operation Torch brought American armor ashore in North Africa. The 2nd Armored Division's tanks landed near Safi and Fedala, equipped with SCR-508 radios that would soon demonstrate their overwhelming superiority compared to German communications. The Afrika Korps, despite being Germany's most experienced armored force, labored under severe communication limitations that crippled their effectiveness. A standard German tank platoon consisted of 5 vehicles, but only 1 or 2 of them carried full FUG-5 transceivers capable of both transmitting and receiving messages. The remaining tanks were equipped only with FUG-2 receivers. This meant they could hear orders coming from above, but they couldn't respond or report what enemy positions they had spotted. German tank platoons operated under a rigid command structure. The platoon leader would transmit orders, and subordinate tanks would acknowledge through physical actions rather than radio responses. When the command tanks were destroyed, and they were easy to spot because of their multiple antennas sticking up from the turret, entire platoons would lose all coordination and cohesion. This vulnerability would become catastrophic when facing American forces, where literally every single tank possessed the capability to assume command functions if needed. The Battle of Kasserine Pass, which raged from February 14 to 24, 1943, provided the first major showcase of American radio superiority. Although tactically the Germans achieved a victory, the battle revealed capabilities that astonished every German observer who witnessed them. During the chaotic fighting that swirled across the landscape, scattered American 1st Armored Division elements maintained perfect coordination across 50 miles of battlefield. Tank crews who had never trained together coordinated attacks, warned each other about threats, and called for artillery support through communications so crystal clear that it seemed almost magical. German signals intelligence units who were intercepting American radio transmissions noticed something remarkable: the exceptional clarity and coordination of these American communications. The 10th Panzer Division's intelligence section filed reports noting that American units maintained communication at ranges where German radios produced nothing but static. What disturbed them even more was the growing realization that every single American tank seemed capable of full transmission, not just the command vehicles that commanded the formations. The German FUG-5 radios, which operated using amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental design limitations that couldn't be overcome. The 10-watt transmitter struggled to reach 2 or 3 kilometers under ideal conditions, but when tanks were moving across rough terrain, the effective range dropped to just a few hundred meters. Every spark plug that fired, every electrical motor that hummed, every track that clattered across the ground generated interference that the AM systems simply couldn't filter out. By September 1943, American armor arrived in Italy, where the mountainous terrain should have negated any radio advantages. Instead, FM technology proved even more valuable under these challenging conditions that rendered German AM radios completely useless. The SCR-508's frequency modulation handled the complex multipath interference created by mountain valleys far better than any amplitude modulation system ever could. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely. During the advance toward Cassino, American armored units demonstrated capabilities that German military doctrine said should be impossible. Tank platoons separated by ridgelines coordinated attacks with precision that traditional tactics said required direct visual contact. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced absolutely nothing but static. When June 6, 1944 arrived and Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with naval fire support, a kind of coordination that would have been impossible with German technology. However, the fighting in the hedgerow country revealed a critical problem. Tank radios couldn't communicate with infantry radios because they operated on completely different frequencies. The infantry's SCR-300 operated in the 40.0 to 48.0 MHz range, which was utterly incompatible with the tank's 20.0 to 27.9 MHz range. This communication gap created deadly consequences in the bocage. where German soldiers armed with Panzerfausts could creep close to American tanks, while nearby American infantrymen had absolutely no way to warn them. American soldiers solved the problem with characteristic ingenuity within just a few weeks. Tank crews mounted EE-8 field telephones inside ammunition boxes that were welded to tank exteriors, with wiring running directly into the internal communication systems. By Operation Cobra in late July, this simple modification revolutionized how tanks and infantry worked together. Between July 25 and 30, 1944, Operation Cobra demonstrated the complete potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented levels of battlefield control. German defenders from the Panzer Lehr Division faced an enemy that seemed to possess almost supernatural awareness. American tanks responded instantly to threats reported by other units miles away. Artillery strikes coordinated through tank radios arrived within minutes of target identification. The contrast with German capabilities was stark and demoralizing. Panzer Lehr, once Germany's premier armored division, had been reduced to communication poverty. Most tanks operated completely without radios, depending on visual hand signals in terrain where visibility rarely exceeded 100 meters. The few radios that still functioned suffered from interference and such limited range that effective coordination became impossible. The irony cut deep. Germany had pioneered radio use in armored warfare. Heinz Guderian, the brilliant architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920s. His book, Achtung Panzer, published in 1937, had emphasized communication as absolutely essential to armored operations. Guderian himself had developed radio communication systems that enabled tank officers to coordinate attacks across vast distances. He understood fundamentally that rapid armor advances required reliable communication systems. Yet by 1943, German tank production couldn't provide the radios that Guderian's own doctrine demanded. The production statistics revealed the crisis starkly. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG-5 transceivers. Many of those radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Soviet tank forces suffered even worse shortages. The T-34, despite being the most produced tank of the entire war, typically entered combat without any radio equipment whatsoever. Soviet doctrine relied on flag signals and detailed pre-battle planning, an approach that produced catastrophic results against German forces in 1941. By 1943, Lend-Lease assistance provided some relief. American radios, including SCR-508 sets, began equipping Soviet command tanks. But even by war's end, only about 25% of Soviet tanks carried radios. The comparison highlighted American achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radios, America achieved 100% deployment of sophisticated FM systems. Motorola's Chicago factory represented American industrial mobilization at its peak. Before the war, the company manufactured car radios for civilians, but converting to military production required completely retooling the facility and solving unprecedented technical challenges that had never been faced before. Each SCR-508 required 2,448 individual components, manufactured to exacting standards and specifications. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite temperature extremes, ranging from freezing to scorching heat, and despite the constant vibration of combat operations. The production statistics told the story of American industrial power. In 1942, 3,800 SCR-508 family radios rolled off the line. By 1943, that number jumped to 11,400 units. In 1944, production reached 24,000 units. The total wartime production exceeded 50,000 tank radio sets, a production achievement no other nation approached. This production miracle ensured that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment. The SCR-508's advantages extended far beyond simple frequency modulation technology. Crystal-controlled frequency stability meant tanks could preset their channels before a battle and maintain alignment despite the chaos of combat. German FUG-5 radios, which relied on variable capacitor tuning, constantly drifted off frequency as temperatures changed and vibration affected their components. The dual receiver configuration allowed commanders to monitor their platoon net and the company command net simultaneously. Orders flowed down the chain of command instantly, while commanders maintained complete awareness of what subordinate units were experiencing. The BC-606 intercom system integrated seamlessly with the radio, allowing all crew members to alert the commander to threats the moment they appeared. Throat microphones and noise-cancelling headphones enabled clear communication during the deafening roar of combat. Many German tanks lacked intercoms entirely, forcing crews to communicate through touch or by shouting over the noise. Power management provided yet another American advantage. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to whatever power was available. The dynamotor power supply offered something the Germans never managed to achieve: clean, stable electrical power that filtered out the noise and interference that plagued every other system on the battlefield. When German radios drew power directly from vehicle batteries, they picked up every spark, every electrical hiccup as crackling static that drowned out vital communications. The tactical transformation this created in American armored operations rippled through every level of warfare. Combat command structures depended on something German forces struggled to understand: flexible task forces built for specific missions, reorganized on the fly as situations demanded. American commanders possessed a capability their German counterparts envied but couldn't replicate. They could assemble battle groups from different units, mix tank companies with tank destroyers and artillery, confident that compatible radios would hold everything together. This adaptability mystified German officers trapped in rigid organizational hierarchies that their communications limitations demanded. When the 4th Armored Division faced multiple German panzer brigades during the Battle of Arcourt in September 1944, the Germans possessed every advantage money could buy: superior Panther tanks, bristling with firepower, better armor, more experience. Yet American radio coordination turned the entire engagement into a lesson in technological dominance. Every American tank could report enemy positions instantly to every other American tank. Tank destroyers received targeting information about enemy vehicles they'd never see, positioned beyond the horizon but visible through the network. Artillery observers riding in Sherman command tanks called in devastating strikes within minutes of spotting targets. Over 3 brutal weeks, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that made no sense according to the technical specifications everyone had memorized. German intelligence watched this happen repeatedly throughout the war, but drew the wrong conclusions. Combat reports mentioned American coordination, certainly, but German analysts attributed it to training rather than technology. A captured intelligence assessment from September 1944 stated plainly that American tank units demonstrated good radio discipline and coordination, which appeared to result from extensive training and rigid communication procedures. The technological advantage remained invisible to them. German tactics never adapted to the reality of American capabilities. They continued targeting supposed command tanks based on antenna configurations, assuming that one well-placed round would cripple American coordination. They didn't realize that every Sherman could coordinate battlefield responses. They planned ambushes based on assumptions that American tanks would lose unit cohesion when separated from visual contact, completely unaware that radio contact maintained that cohesion regardless of what crews could see. By March 1945, as American forces approached the Rhine, this communication superiority had reached its full devastating potential. The capture of the Remagen Bridge demonstrated exactly how far this advantage extended. When the 9th Armored Division discovered the Ludendorff Bridge still standing, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to exploit the opportunity. German forces dependent on telephone lines that American aircraft systematically destroyed simply couldn't respond with comparable speed or flexibility. American radio coordination created an impenetrable shield around the bridgehead. Tank platoons from different battalions integrated seamlessly, sharing targeting information through radio networks that bound them together. German counterattacks, crippled by their own communication failures, arrived piecemeal and were destroyed piece by piece. By April 1945, the encirclement of the Ruhr pocket demonstrated the full culmination of American communication superiority. American armored columns from the 1st and 9th Armies executed a complex double envelopment entirely through radio communications, something German commanders couldn't have attempted even with superior forces. Inside that pocket, 325,000 German troops found themselves trapped, partly because their communications had simply collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Isolated units lost contact with higher headquarters and with each other. Field Marshal Walter Model's final messages before communication failure revealed the desperation of the moment. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The psychological experience of tank warfare transformed under American radio superiority. American crews fought with the knowledge they were never truly alone. Even when physically isolated, they remained connected through invisible radio waves, part of something larger than themselves. German tank crews experienced something profoundly different. Isolation so complete, it bordered on terrifying. Unable to communicate, they fought individual battles within larger engagements, never certain what was happening beyond their immediate view. Otto Carius, one of Germany's most successful tank commanders, wrote about the challenges of limited communications in his memoir, Tigers in the Mud. Though he focused more on tactical consequences than on the deeper communication gap itself, the strategic implications extended far beyond individual battles. American advances throughout 1944 and into 1945 maintained their relentless tempo, partly through radio coordination networks that German forces couldn't match. The Third Army's legendary race across France depended entirely on radio networks that maintained control across hundreds of miles of rapidly changing terrain. German commanders consistently underestimated American capabilities because they couldn't conceive of the communication advantage Americans possessed. Heinz Guderian, serving as Inspector General of Armored Troops, recognized the problem but lacked the means to solve it. In a December 1944 memorandum, he acknowledged that American coordination negated German advantages in tank quality. It was perhaps the most important admission he ever made. After Germany's surrender, American technical intelligence teams evaluated captured German equipment. Their findings confirmed everything combat experience had suggested. German tanks often possessed superior armor and superior firepower, but suffered from communications equipment that was catastrophically inferior. The U.S. Army Technical Intelligence Report, number 176, concluded that German tank communications were approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities throughout the German force structure. Soviet evaluators reached similar conclusions. The Red Army, given access to captured German equipment, chose to copy American radio designs rather than German systems for their post-war development, a choice that spoke volumes about what they'd learned from the war. The production and deployment statistics tell the story with brutal clarity. American radio production of SCR-508, 528, 538 radios totaled more than 50,000 units. Sherman tank production reached 49,324 units, with a radio deployment rate of 100%. These radios transmitted at 25 watts with frequency stability of crystal-controlled, plus or minus 0.01%. Moving through open terrain, they maintained range of 7 miles. When stationary, they reached 10 to 15 miles. German radio production of FUG-5 transceivers totaled only approximately 6,000 units. German medium and heavy tank production reached approximately 12,000 units, but only about 20% received full transceiver deployment. These radios transmitted just 10 watts with frequency stability of variable plus or minus 1%. Moving, they barely maintained half a mile to 1 mile range. Stationary, they reached only 2 to 3 miles. The communication effectiveness numbers revealed the gap. American fire missions took 3 to 5 minutes from spotting to receiving fire support. German fire missions required 15 to 30 minutes. American tanks achieved coordination across 100% of their force. German tanks with full communication capabilities comprised only 20% of their total strength. This radio superiority established principles that govern armored warfare even today. Modern main battle tanks carry communication suites that trace their lineage directly back to the SCR-508. They're digital rather than analog, certainly, but fundamentally built on the same principle of universal deployment and reliable coordination. When the German Bundeswehr rebuilt in the 1950s, they prioritized communications based on the hard lessons of World War II. Every Leopard tank manufactured carried comprehensive radio systems. A Bundeswehr training manual explicitly stated that the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts have validated this lesson repeatedly. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks, but inferior radios. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than any advantages in armor or firepower could have achieved. German tank crews fought their war partially blind to this revolution, discovering far too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a component of something much larger, a weapon system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower could possibly have achieved. Every Sherman carried the tools of victory not just in its 75mm gun or sloped armor, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew fighting nearby. This connection created a collective intelligence that no individual German tank, regardless of superiority in armor or firepower, could match. German forces discovered this reality through bitter experience. At Kasserine Pass, in Italy's mountains, across France's hedgerows, and in Germany's final battles, American tanks demonstrated coordination that German doctrine said was impossible without visual contact. The Germans never developed an effective counter because they never fully understood the technological gap. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," captured a fundamental truth, whether accurately quoted or apocryphal. America had built not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform, and the connected would overcome the isolated. This transformation occurred largely invisible to German forces. They saw American tactical superiority, certainly, but didn't recognize its technological foundation until far too late. By the time German commanders understood that every Sherman tank possessed communication capabilities that most German tanks lacked, the war was effectively decided. The German military's failure to recognize and adapt to American communication superiority stands as one of World War II's great intelligence failures. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving their critical communication weakness. They continued building superior tanks that fought as isolated individuals, while American forces built adequate tanks that fought as coordinated teams. In the end, the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns. The ability to coordinate, to share information instantly, to fight as a unified force rather than as individual vehicles determined victory more surely than any visible superiority in armor or armament. The Sherman tank's radio superiority changed warfare forever, establishing the principle that in modern combat, connection equals survival and isolation equals defeat. German troops discovered this reality on battlefields across 3 continents, learning too late that Americans possessed not just numerical superiority, but technological superiority in the dimension that mattered most: the ability to fight as one.